Interestingly as well, Python doesn't provide privacy options for its variables and methods. There is no way to bindingly mark a variable or method in a Python class as private, meaning that other code can always access variables directly. By convention, we often precede variables or methods that we don't want other classes or functions to access with a double underscore. So preceding init with a double underscore is a way of saying, don't try to run this method directly. You can, but you shouldn't. The double underscore simply informs other areas of the code that those methods or variables are not meant to be used to access data that way. Now, part of this is what we call Pythonic style, which focuses on easy access to data. This is actually related to the ease of Python's lists and dictionaries. Other languages supply these as much more traditional classes with tougher syntax. So generally, when you're developing classes in Python, it's okay to directly access variables like balance here. That's a major taboo in some languages, but it's kind of accepted in Python. But that said, getters and setters have other purposes as well. Recall that part of the benefit of getters and setters was that they allow us to run some code whenever a variable is accessed or modified. We see that here. We have a getter called getBalance, and every time we try to get the balance, we're logging the fact that the balance was accessed. So let's try to implement the bank account class that we've been talking about for a while. We'll start with class bank account, just the same way we define any class. And I'm going to define 4 different methods for this class. One of them is our initialization constructor. What it's going to do is create a name and a balance using the initial balance passed into the constructor, which we'll assume has a default value of 0. We could override that initial balance, but if we don't give a balance, we want to assume that the balance is 0. It's also going to log the fact that the account was created. We'll talk about the log method in a second. Second, I'll have a getter for getting the balance. Its main function is to return the balance, which is the same thing as accessing the balance directly. But it's also going to log every time the balance is checked. It's going to do so by printing that the balance was checked when the balance had a certain value. And because log is not print, we can't assume an implicit conversion to string, so we're going to convert that value into a string and then concatenate that with that label. Third, I'll create a setter, which does effectively the same thing as the getter, but instead of returning the value, it sets the value equal to a new balance. And it also logs that as well. And then fourth, I'll create that actual log method. That log method will take as a parameter the message to be logged, and its operation is to automatically open my log, print the message to that log, and then close that log. So every time an account is created, or the balance is checked, or the balance is changed, those operations will get logged to my log file. That's the value of getters and setters. I can do more than just give access to the variable or change its value. So as before, when we execute this code, it encounters class bank account on line 2, and that's just loading the idea of a bank account into working memory. So it skips, for now, all the code indented under class bank account. It's not going to use those until it needs them. Then on line 22, it needs them. We create a bank account with the variable named myBankAccount and with only one argument, David Joyner. Name was not a keyword argument, so this argument is required. Now, this kicks execution up to our init method, where it's going to log that an account was created. It's going to set the name of the account equal to the name put in this case, David Joyner. And because no argument was given for the balance, it'll set the balance equal to the default argument, 0. So after line 22 executes, we have a variable called myBankAccount. It has a name, David Joyner, a balance of 0, and a line has been logged to our log file, saying that an account was created. On line 23, we call myBankAccount.setBalance with the argument 20. That kicks execution up into the setBalance method, specifically for this instance of bank account. 20 is the argument, so it comes in as the new balance, and so now self.balance is set equal to new balance. And that fact is logged. Balance was changed to 20. Once it's over, execution is kicked back to the main program, and line 23 is done running now. Line 24 will then print the value of myBankAccount.getBalance. But calling this method, once again, kicks execution up into the getBalance method, where the first thing it does is log that the balance was checked at a certain balance. And that's again what we see in our log file. It then returns self.balance down into that print function, and so this becomes print 20.0, because that was the value of balance at the time that getBalance was called. And so that's what's printed to our output. Note that constructors, destructors, getters, and setters are 4 common paradigms for designing methods, but it's certainly not an exhaustive list of every type of method we could create. We could actually create methods to do whatever we want. And in fact, if we were really designing a bank account class like we were designing here, we probably don't want a setBalance method. How often do we just wipe out the previous balance and set it equal to a new value? That's not the way we usually use bank accounts. Usually we use them by making deposits and making withdrawals. So here I've revised our bank account class to get rid of the set balance method and instead have a method for depositing money and a method for withdrawing money. Instead of just changing the value of balance to whatever is put in, it adds or subtracts that value. They still persist that same logging though, and I've temporarily truncated our log method just so that I can fit everything on the screen. But really, its contents would still be here. So down here in our main code, creating a new instance of bank account and setting it equal to the variable named my bank account will still trigger the same logging statement, account created. But now instead of setting the balance, I'm going to make a deposit. I'm going to deposit $20. That kicks execution up into the deposit method, where my balance is set equal to itself plus that amount, and then it logs both what was added, plus amount, and the new value. So here, plus 20, and my new value is 20. I then check my balance at 20, and it confirms and logs that my balance was checked at 20. And I print the results of that check, which prints 20 to my output. Then on line 27, I call my bank account.withdraw 10. That kicks execution up into the withdrawal method. It sets my balance equal to itself minus the amount, and it logs that. It logs that we subtracted 10, and that the new balance is 10. 20 minus 10 is 10. And then finally, we check it once more, which both causes balance checked at 10 to be logged and 10 to be outputted, because we're printing the result of my bank account.getBalance. So now we've created a somewhat realistic class to contain the way a bank account is actually used in the real world. And what's particularly notable about this is that it mimics the way we think about real bank accounts. We think about them in terms of deposits and withdrawals. And so we named our methods for depositing and withdrawing, deposit, and withdraw. The power of object-oriented programming is its ability to let us write programs that mimic our own understanding of the world. We know that a bank account has a balance, the ability to deposit into it, and the ability to withdraw from it. And so our bank account is structured according to our knowledge of that real-world idea.